We now have 4 minutes to discuss Ethereum's ENS scaling.
Okay, well, so what events what events actually need to be ordered, right?
Yeah,
there's a few clear events that do need to be ordered, right? Whether reveals or bids come in before certain timeouts. Like that, there needs to be consensus on that, right? And that means that like the auction probably needs to be pretty named, probably needs to be on the same shard. Like you're probably not going to be talking about multi-shard auctions. Like you accept that outright. So so auctions are sequential, right? Individually sequential, but they can be run concurrently because they're on different names. Unless maybe you have, I think that's true, right? That's definitely true always. Yes, I think so. And so after you win an auction, you have a bunch of things that you can do with that name, and I would presume that those need to be, any changes to the name need to be applied sequentially.
Yes.
Okay, so let's assume that operations on the same name are sequential, right?
That's not necessarily true. There's only 2 things you can do with the name. 3 things, sorry. You can change your own search, you can change what the resolver contract is, and you can create subdomains.
Okay.
Ordering matters.
Ordering matters for all of those. All of those.
You can't create subdomains if you don't own it. You can't.
No. You can't. If you have two change the owner transactions, you can't. You need to process one of them first.
Yeah.
Or to change the registrar transactions.
Setting subnodes.
Exactly. Yeah. So you need to order them within each other, but not between each other. Oh, look, even between each other, but except for the owner, right? So for the owner needs to be ordered with all the other ones, but not. But say like changing the owner doesn't need to be ordered with changing the registrar. So like if you change the registrar, resolvers, right?
There's nothing there that prevents you from just putting each name on its own chart.
Let's just assume that each name is processed sequentially for simplicity. So every operation on each name is processed sequentially. Okay, great. So then we have like everything for each name sequentially for everything that has to do with each name. Great. And then so then the next question is, okay, how do we split up this namespace across different shards and load balance? So one idea is if we have n shards, well, we kind of like hash mod n, or like do some operation in mod n in order to stick names on different shards. You look at the name, and you do this operation and see what shard it's on. But if n increases or changes over time, then it's going to be a fine, but you're going to have to like learn about the shard count, and then figure out where the name is stored. The other question is actually about how will the contract. This is actually kind of related to sharding, right? Will you have to redeploy, or how does it actually move to migrate names, right? So what's going to end up happening is, I screwed up. You can't just figure out from the hash of the name with the mod which bucket it goes in because of load balancing, right? We need to keep a map that says on which shards which names are on.
So you can kind of distribute things like DHTs.
Yeah, you don't even need a THT.
The THT structure, which is every shard has a random ID, and the IDs that are closest to that, one that's close to that shard.
Right, so you got a new shard in between 2, and then you migrate it.
So here's an idea.
But now we're designing shard.
So here's you hash the name, and then with I don't know, and then you use like mod number of shards to figure out on which shard the location of that name is stored. Right? You figure out where that name is stored, and like so you might go to shard 2 to find out that the resolver of this name is on shard 4. Then I'll go to shard 4 to do that, right? Because that way that name can move in to do load balancing.
So if we assume for a moment that any sharding solution you come up with has some way of balancing contracts across shards.
So that's actually not something I'm happy to assume because like I'm the only guy who loves load balancing shards like so far. I mean,
okay, some way to map from a contract address to which shard it's on.
That's So like at the moment in all the solutions we look at, you just like look at the name and figure that out deterministically from the name of the contract.
Right. You mean the address?
The account number.
Yeah. So under that assumption, all you need is some way to go from a name hash to the address of the contract, and then you can look up where that contract is on the shard.
But how do you know that contract will be able to resolve your name?
So Vitalik came up with this the other day when we were discussing stuff, which is with Metropolis Part 2, Constantinople, the address of the generated contract will depend on the bytecode of the contract and the address that is creating it. If we have a standard contract bytecode for ENS resolver node or resolver contract, and then you append the the name hash that it's for, then you can now deterministically figure out what the address of that contract will be if it exists.
Wait, sorry, hold on. What's the contract address determined by now? Nonsense.
Now it's
unsender.
yes.
Yeah.
And what's gonna be later?
It will be the hash of the bytecode and the sender.
And
Instead of the
Probably also nonce.
No,
It's even
no,
similar to
no,
not.
no,
No
no.
nonce? So what if you deploy the same contract twice, they can't?
Yeah.
It will fail the second time if the first contract still exists.
So you
Oh,
have
so
to
then
like
it'll just-
rotate.
It'll have a rotating
If
thing.
you
It's almost like a nonce per
Okay,
possible
wait,
address.
but so in that case, like when we're talking about deploying the same contract for ENS,
You cycle a byte that you never use somewhere.
No. You append the name hash of the the hash of the subdomain you're creating to the bytecode as a constructor parameter,
Yeah.
and that gives it its own
Okay.
address, which means that if you know the address of the
so then you can
ENS
determine
root,
this do
Sure, you can
everything
write that
just
any
from the name
contract.
hash.
Right.
So basically, if you figure out the name of the contract that should be holding that
and
thing.
see if it exists.
Because
If it
all
does, you have a
deterministic
contract
based on
error.
But it might not actually be holding it because any of these things can become overflowing.
But I thought our premise here was that you have a way of mapping from a contract address to where you find it.
Yeah, you
You
can't.
can, but you don't know which contract address will have your name. No, you don't.
Each contract, it contains only one name.
And it's all deterministic,
Okay,
so it
yeah.
should be hypothetically where it's
Okay.
deterministically that it should be.
No, I got it. If you have a single name, a single contract per name,
Yeah.
then that will be fine.
The really cool thing about this is that these contracts can effectively be proxies for implementation. The owner determines what that implementation is, which means that suddenly instead of ENS having a single central registry, set of registrars and set of resolvers, it just has this one contract. And lookup's the one step where you call it and it doesn't tell it, it calls the implementation or whatever. And everything can now be integrated into a single front end or a single interface.
Which would then also reduce gas costs.
But then you'd be making cross-shard calls from every shard to this one contract and this one shard?
I mean,
cross-shard
probably have
routing calls.
multiple.
Well, every name will exist on one shard, yes.
But different names will exist on different shards.
Yes.
And all these delegate calls are going to which contract?
They can go to whatever contract the owner wants them to go to. And if they want to, it would be sensible for them to deploy that on the same shard if they can. As the name.
I mean, is it realistic to just say that like every shard will have one of these contracts?
Which contracts?
Like
ones
the
that
one that we're doing the delegate call to? Because
Yes.
that's like the part of the ENS that's like basically duplicated over and over and over again right now.
Yeah,
We basically put that on chain separately to Robinson, right?
Yeah, you can write library contracts that anyone can point to, just like we have for public
It
resolver right
deduplicates
now.
bytecode storage,
Yeah.
and it makes it possible to redeploy a contract, a different contract at the same address.
Right.
Constantinople does, yes.
If there is already a self-destruct mechanism built into it.
Right.
So it's not possible to just do it generically.
Or maybe one day rent.
Yeah, right? That just like,
That almost sounds like.
say it again, say it again.
It's upgradable contracts. You can replace what's there
Yes.
by self-destructing and redeploying.
Right, because
Same
since the address
Which also is
by
scary.
the bytecode in the sender, that means that if you self-destruct the contract, it's no longer there, so you can upload the same.
It's not the same thing as it was before, but it's the same address.
But it depends on the bytecode of the contract, then you cannot change the contract.
You can't
always-
change it. Right.
You can,
Right,
yes.
So it's not
You can write a contract that just
You can
goes on
initialize
the
different-
bytecode
You
from
can
somewhere
purchase
else.
state, so any local variables in the contract,
There
you
you
can
go.
merge and reset.
Sorry, I
So
think-
if you had a full registrar with all the names and you didn't like how it was, you can pull it, redeploy it.
So it sounds a little
What's the
safer.
advantage?
What would that say? Well, I don't know, what, you know, it has
Wait,
the same
sorry.
whoever hypothetically did.
Wait.
I was wrong when I said that you
Reinitialize
could
it.
change it, but you can
You know,
reinitialize.
I think the reason why this happened is.
No, you
because
can
there are
change
single
it.
numbers.
You can, all you need is your constructor code, is call this other contract and get back some
Sorry,
bytecode.
you can because you can deploy a clever contract.
Yes.
That its bytecode won't change, But it
It's
always.
constructor bytecode
delegates to
won't
something
change.
else.
No, it's constructor bytecode
Yeah,
won't
yes.
change, but its final bytecode can.
Yes.
And this
Dependent
is-
on external variables.
This is in fact one of the reasons that
This is
Whoa.
weird.
Yeah.
It could just be a pointer to something else.
Yeah.
yeah, and you guys have.
this is
Okay,
one
wait,
this is
wait,
one of the
wait.
reasons that Metropolis was split into two,
Yeah, that
because
makes
this
a lot of
was the
sense.
consequences of this are enormous.
Huge.
They're
Okay.
huge.
Oh,
Yes.
wait, I have a question though.
Maybe.
Would like, are we basically like creating a system where like we're gonna have a lot of these like fake empty contracts that are just eating up space, like
No, it also has deduplication.
It can
involved.
deduce.
Yeah.
so in the long run we're saving memory over it.
We only ever write bytecode for any contract once.
We already do that, to be clear.
Right.
Okay, yeah, alright.
And if we want to do sequence number abstraction, gotta get rid, we want to get rid of sequence numbers. Sorry,
Nonsense.
nonsense.
Which is
So
not what
we should have been called sequence
Yeah,
numbers all
yeah, I
along.
agree.
If we get rid of the sequence numbers,
Uh-huh.
then we're not gonna be able to use them to determine addresses for contracts.
Why are we getting rid of nonsense?
Because we want to count
Oh, for
abstraction.
abstraction, okay, got it. But then, so what about double spending?
You have to implement your own NP double spend.
Yes.
So most people will initially use a standard
I'm
account
so
contract that
excited
does that
now.
for you.
Yeah.
Yeah.
It's gonna be great.
Yeah.
Tell users to implement their own.
Yeah,
their own
okay, so
security
my
account.
development, like 6.0 will just basically be like, hey guys, you're gonna have a new account and like basically, you can double spend unless you like write something right here that like says that you don't. And like Ethereum totally, we're just going to the moon, right?
It's not like double spending, it's replay attacks though, right?
What?
Yeah.
It's replay attack, not double spend.
Right.
Well,
It's
it's
kit.
both.
No.
Well, the nonsense, I mean,
Without without replay text.
Replay
Yeah.
attack.
Yeah.
Replay attack is a type of.
It's just that you can submit two transactions.
No,
and not-
replay is not a double spend.
okay, so double
Yeah.
spending works by
I think I would
basically
do that
submitting
online.
2 transactions at approximately the same time and what was their velocity.
Like,
And expecting the one to go through and like get like in the pending state faster.
Yeah, sure.
I guess, but I
That's
mean,
zero
if we
cost,
reduce
you're
the
trying to get
velocity,
zero cost double spend.
if we reduce, I mean, it's really easy to double spend on Bitcoin, by the way, like really easy.
Well, on
like-
zero cost.
But, yeah, well, yeah, I mean, that's it's assuming that like, you know, the person on the other end is like sees it and it's like, okay, cool, and then like goes and does something and then you basically rebug it or replace it or whatever you want.
Before he's on.
Okay, but if the block times are fast enough, then it's really hard, but then you just erase.
Yeah, so as soon as it gets in the blocks, like the first one that gets in the blocks wins, and like that's kind of like the
I
story
mean,
for the double spending. But
I will say that like trying to double spend successfully like super fun and like fun.
that's fun, yeah, but I'm saying this is about replay attacks, not double spend. The blockchain solves the replay, the double spending. The replay attack is just that you give me $10 once, and I like cashed it out 20 times. I'm not double spending you.
You just submit
You
the
know,
same transaction.
you're spending to
over and
me.
over. Yeah.
Okay, yeah.
What is the
And cash art.
multi-receiving
Yeah,
transaction ID instead of number?
What is the gas cost of registering the thing?
I don't get any of
Around
this.
about 150, well, no, it depends which transaction you're talking about.
I really like.
It depends on which transaction you're talking about. The different parts of the registration vary from about 80,000 to about 200,000 gas.